In this video, we're going to prove the equality that you see on the screen, which is one of the equalities known as the Sophomore dream. First, some basic information. We know that the function x to the power of x does not have an elementary antiderivative, so you cannot just apply Barrow's rule and substitute the limits. Of course, you can always evaluate the integral of x to the power of x from 0 to 1 numerically, and you would get something close to 0.78. But our goal is to prove that this integral is equal to the negative summation of negative n to the power of negative n from 1 to infinity. So we start with the original integral. Knowing that the exponential and the natural log are inverse functions, we can write the integrand as you see here. Using the properties of logarithms, we take the x out of the logarithm and to the front. And why is this useful? Because we know the series expansion of the exponential function, which is relatively simple. So we write the exponential function as the sum of the exponent to the power of n divided by n factorial from 0 to infinity. Now, by uniform convergence of the power series, we change the order of the integral and the summation. And after doing this, we take the denominator out of the integral, since it does not depend on x. Now, the next steps involve the explicit calculation of this new integral, which, unlike the original integral, for this one we can obtain a closed form solution. First, we will perform a change of variable. In particular, consider the following u substitution. You will see in a moment why it comes in handy. Solve for x and derive in order to obtain the differential of x. And plug x and dx into the integral to obtain an integrand that only depends on u. Also, don't forget to change the limits of integration, plugging 0 and 1 into the expression of u. The new limits of integration are infinity and 0. And here I have also applied the nth power to each term in the parentheses. Rearrange similar terms and also use the negative sign to swap the limits of integration. Multiply the similar terms while also taking into account that some terms only depend on n and you can get them out of the integral. Now, this integral that we had on the right is the gamma function of n plus 1. And since n is a natural number, the gamma function of n plus 1 is just n factorial. So now we go back to our original problem. We just computed the integral that was inside the summation, so we substitute the result. Notice that we can cancel out the factorials, and that leaves us with only the term in the middle. You can add an extra negative sign, so you can raise everything to the power of n plus 1 inside the summation. And just move the denominator up by putting a negative exponent. So we are almost done. The only thing left to do is to change the index at which the sum starts. If we start at n equal to 1 instead of n equal to 0, we simply replace n plus 1 by n. And the summation, which is the one you see here, looks nicer. Thus, we just proved one of the identities that receive the name of the Sophomore's dream. There is another version that has exponent negative x instead of x in the integral, and it is typically known as the main identity of the Sophomore's dream. I covered that integral in my previous video.